we want to solve this quadratic inequality. The answer is not going to be a number. The answer is going to be a solution set. So a set of numbers that satisfies that inequality, right? It's not just one number. It's a set of numbers. So we're going to start off just as if it was a quadratic equation. So pretend that that's an equal sign. And we're going to pretend that it's an equal sign and find our critical values. The critical values are the values that are the solutions to the related quadratic equation. So if that were just an equal sign, I would factor x minus 3, x plus 1, and I'm going to say equals 0. This is the related equation. Yeah. I made it an equals 0. That's the related equation. From that, we're going to find our critical values. And the critical values are x equals 3 and x equals negative 1. Those are the critical values. And what that means is that those numbers define the solution set. They're like the endpoints of the solution. So then I'm going to plot them on a number line and we'll figure out what the actual solution is. So here's my number line. So let's make that 2, 0, negative 1, negative 2, negative 3, negative 4. Oops. I did the negative when I wanted the opposite of that. So I'm going to have to make that a little longer. Critical values are here and here. Closed circles, right? Because it's a less than or equal sign if we look back. What we need to decide now is, where are the solutions? Is it these numbers down here? Or is it the stuff in between? Or is it these numbers out here? And it's probably going to be either the stuff in between or both of these two other regions. But those are the numbers that define the regions, those critical values. So yeah, I'm going to verify. I'm going to test. So I'm going to pick a number in each region and test it in the original inequality. I'm not going to pick the critical values. They're going to come out to equal to 0. Which one do you want to pick?
0.
Pick 0 in the middle. I always like to pick 0 because it's easy, right? So I'm going to go 0 squared minus 2 times 0 minus 3 is less than or equal to 0. So I'm taking the original inequality and filling in 0 for x. And I get negative 3 is less than or equal to 0. Is that a true or a false statement?
True.
True. So put a little check mark there in that region. That means all the numbers in that region should be true. Any of them that I test. I think these other ones are going to be false on the outsides, but I'm going to quickly test them anyway just to see. So I'll pick like negative 2 on the left. And that comes out to, that's 5 is less than or equal to 0. True or false? False. So it's not that. And if I quickly also test for that also, does that come out to 4 or 5? 5? It's less than or equal to 0, so it's also false. What that means is, if I'm going to plot the solution set, oops. It's right there. It's between those two values. So one thing you might have to do is plot it on a number line. That's what it would look like on a number line. How would you describe that? So what would you say the answer is in word? Yeah, go ahead.
So it'd be like x is in the middle, and like x is less than or equal to negative 3, x is less, more than, greater than or equal to negative 1.
X is greater than or equal to -1 and less than or equal to 3.
Yeah.
Yep, that's it, and that's how you write it. As one statement with x in the middle. But you read that from the inside out. So you go x is greater than or equal to -1 and less than or equal to 3. They both look like less than or equal to signs. But if you read it backwards, it's greater than. So x is greater than or equal to -1, x is less than or equal to 3. Okay, here's one more. Negative x squared plus x plus 12 is less than 0. So first thing we're going to do again is solve the related equation. So I'm actually going to factor the negative out of this one. I don't like that negative there. So I'll go negative x squared minus x minus 12 is less than 0. And then factor what's left there. So this is going to be x minus 4, x plus 3. Oops, this is the related equation, so that's going to be equals 0. So the critical values are x equals 4 and x equals -3. -3. There's 4, 5. But this time I'm going to put an open circle at -3 and an open circle at 4. Why is that? Yeah, it's not equal. It's just a less than, not a less than or equal to. And then I'm going to test values within those regions. And I like to test 0. So I'll go -0 squared plus 0 plus 12 is less than 0. And I always want to test back in the original equation, or original inequality, the very first thing you were given. Because then if you happen to make a mistake, like with your solving or something, you're not going to make a mistake with this. But you don't want to fill it into an equation that you made a mistake with. So that gives me 12 is less than 0. And is that a true statement?
Yeah,
No. No. So it's not in there. So it's actually probably going to be both of those outer regions, but let's test. So let's test -4. So fill -4 in for x. That comes out to -8 is less than 0. Is that true?
Yes.
So this region is true. And 5 is, I'm sure, going to come out to the same thing. Also comes out to a true statement when you fill in 5. So we go -5 squared plus 5 plus 12. -25 plus 5 plus 12 also comes out to -8. -8, right? It's less than 0, and it's true. So there, those regions out there, when I want to show the regions, it's like this. That's the solution set. How do we write it? The answer is going to be x is less than -3 or x is greater than 4. And you write out your solution set like that.